days ago, say for step 1, to move the 6 over, and then step 2, do any FOIL or distributive properties, that's arbitrary. I like to do the FOIL first and then move the 6 over, so that's what I'm going to do. But it doesn't really matter. You'll get the same answer either way. So if I FOIL first, that gives me g squared plus 3g minus 10 equals negative 6. And then I need to get it equal to 0, so I do what to both sides? Add 6. So that next step is g squared plus 3g minus 4 is 0. That's a trinomial. It's got 3 terms, so you can either swing that or do factor by grouping. If you were not here yesterday or you ever want to see the comparison between the two again, remember I recorded the video yesterday where it compares the factor by grouping for trinomials, things with 3 terms, or swing if you ever want to see that again. It's in Google Classroom. So we need to know what multiplies to AC and adds to B. And it's 4, negative 1. You divide by the A value, which is 1. That doesn't happen to change anything. I will always do that step, though, for consistency. So when A is not 1, we'll still remember to do it. So then that gives me these factors, g plus 4, g minus 1 equals 0. We set that one equal to 0. We set that one equal to 0 and solve it. It's basically just insider's lie shortcut right here. So it's negative 4 and positive 1. Raise your hand if you got that right. All right, pat yourself on the back while your hand's in the air. Good job, selves. Are there any homework questions? What about this side? Still no? Okay. Today's lesson is super short. And before we begin, you need to know that the homework that goes with the lesson is due before you leave today. There's no key. I'm checking it. So, it's a grade. And I'm checking. It's a daily grade. I'm going to check it. There's no key, but it's pretty easy. It's going to go super fast. So I have no guilt, 0 guilt in doing that to you. Yeah, classwork. For the homework for today, for this lesson. It's going to be due before you leave. This is true. The homework is not homework today, it's classwork today. That's correct. Okay, the stuff I'm going to talk about on this screen, usually I tell you, don't write this down, I want you to just listen. And I still want you to listen today, but I want you to also write it down. So this is called the square root property of equality. It is another way to solve quadratics, specifically ones where you can get it into the form of something squared equals a constant. So all these like math symbols right here are telling you this. This capital X can represent a variable, or it can represent an expression, like x plus 4 is an expression, for example. If you have something squared equal to a constant, then the solution is the positive square root of that constant. We call that actually the principal square root. It means the main one. It's either the principal square root or the opposite of the principal square root, right? We're used to calling that plus or minus, whatever your answer is. And so anytime you're introducing the square root to solve something, you need the plus or minus version of whatever that constant is right there. And it doesn't matter if your answer, after you take the square root, you could have a radical. After you take a square root, you could have an I. After you take a square root, you could have an integer. It doesn't matter what form it is, they all have the plus or minus in front. So here's a couple of baby examples. So we know already, if you have x squared equals 9, and you take the square root of both sides to solve, x doesn't equal just 3, it equals plus or minus 3. And that's two distinct solutions. Since the power or degree is 2, we know we have two answers. But just to jog your memory, 'cause sometimes we just get on autopilot and we just say plus or minus. Here's what's going on. If you were to take this 3 back into the original equation, if you put positive 3 back here, that's a true statement, right? 9 equals 9. But even if you put the negative 3 back in for this x right here, it's times itself. That's what squared means. Would that be a true statement? Yes, because negative 3 times negative 3 is positive 9, and 9 equals 9. So that's why we have the two different solutions, because you're squaring, and so both positive and negative would work. But I'm going to change that original thing just a little bit. I'm going to keep pretty much everything the same. What have I added in? What did I change? What was the modification there? The 9's still there. Listed the factors. How did I change the x? Like it's no longer just x squared. What is it? Minus 4 squared, right? So this is a variable. This is an algebraic expression. There's a number and a variable, x minus 4 squared. But we still begin the same way. We still take the square root of both sides. Notice this is a squared term equaling a constant. Okay, the property we're learning today is very specific for this situation. Something squared equals a constant number. So if I square both sides, on the right-hand side, I still get positive negative 3, just like I did before. But on the left, the root cancels out the power, and I'm left with what's underneath. That's called the radicand. X minus 4 equals plus or minus 3. So we have released the x from the bondage of the power. That's very dramatic, right? It was sad. And now in order to solve for x, I have one more thing I have to do, which is what? Because now x is free. And it wants to be isolated. How do I undo this minus 4? Plus 4? So x equals 4 plus or minus 3, which is true, but it's not finished. There is more math I can do here because all of those numbers are integers. This represents two different solutions, and let me tell you what it does not represent. Okay, it does not represent not this. It's not plus or minus 7. People just see that 4 plus 3, the 7. So obviously the other answer has to be negative 7. But slow down a little bit. That's really not what's happening at all. It means that I have 4 plus 3, which is 7. But then I also have what? 4 minus 3. And what is that? 1. Okay. So the answers there are 1 and 7, not 7 and negative 7. And I was just going to make a slightly inappropriate for school joke about something, but I did not because I'm recording and I'm learning. Right? It's like I can learn. You're never too old to learn. Real quickly, do you know what root vegetables are? No, root vegetables are things that grow on the ground. So like potatoes, carrots, turnips. And so you have to kind of know that in order to get the joke. Your mama thinks square roots are vegetables. I thought that's cute. My own personal children, of which I have 5, they tell each other your mama jokes, and I'm like, that's not how it works. You all have the same mom, so it's a fail. They think it's funny. And then I'm always like, I'm not fat. No, I don't tell them, because your mom is so fat. I know. All right, thank you. All right, so to solve a quadratic equation using square roots, this is all, it looks like lots and lots of words, but it's basic ideas that you already understand. For example, step 1 says isolate the squared expression, okay? So you have to isolate whatever it is that has the power of 2. The second thing, then once you do that, then you take the square root of both sides. Don't forget your plus or minus on the constant. Whatever's on that right-hand side gets a plus or minus. Then simplify the radical if possible. Sometimes it will be, sometimes you can't. Move any constants over. And in this last note, we're actually going to cross that out. It says if your squared expression is equal to a negative number, you have no solution. So we've talked about this kind of already. For example, if you had x squared equals negative 4, that's not actually true, right? There's no number squared that will give you a negative number. So this really should say has no real number solution. Because if we were to take the square root, knowing what we know now, how have we been practicing dealing with negatives under radicals? What tool do we have? We have I, right? So instead of, we're going to scratch this part out of our notes, and we're going to use the imaginary solutions. So this is supposed to say, this was going to mean if it's a negative under the radical, say there's no real solution, but we're not going to do that. We're going to use the imaginary solution because we've been practicing that, so we're going to use it. Similarly, on the examples in your homework, you'll scratch out this last sentence right here. If there are no real solutions, so state. We're not going to do that. We are going to give the imaginary solution. All right. So now we have this example. My first question is the very first step. Is the squared term isolated? No. So this is the squared stuff right here, b minus 3, and it has a plus 7, and we need to move that over so that we can square root both sides. How do I move a plus 7 over? Subtract it. So b minus 3 quantity squared is 6. So now this is that general form that was at the beginning of the notes. I have something squared equal to a constant. And now I can square root both sides. Square root, square root. The left, the power and root cancel out, leaving me b minus 3. And on the right, I have square root of 6. What have I forgotten, though? Plus or minus on the radical. And I have one last step. What is it? To solve for b. Get the variable by itself. I need to get the negative 3 out of there by doing what? Adding 3. So b equals 3 plus or minus radical 6. I can't simplify that radical, so it stays like that. You can also write the radical first, like this, if you wanted to. Square, plus or minus square root of 6 plus 3. It's whatever you like. Any questions about that? Next slide. What's funky-ish about this problem? The fraction, okay? But the first question still is the first question. Is the squared term isolated? Yes, right? There's nothing else on the outside of it, so it's all alone. So because that's true, we can go ahead and square root right now without doing any other stuff. So square root, square root. On the left, that leaves me x plus 2. On the right, it gives me positive and negative. And what did we talk about last week? How do you handle square roots that's a fraction? What do you remember? You make two different ones, right? You make a radical for the numerator and a radical for the denominator. And you simplify them separately. Which one is a perfect square? 64. So what is that going to be on the bottom? 8, okay. And then for the top, you need a little baby factor tree. You don't need a full-grown factor tree. It's a small number. So take a minute, factor 27, and do your simplifying. Raise your hand when you've simplified radical 27. Yes, 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 yes. Kat, what'd you get when you simplified radical 27? 3 radical 3. Okay. If you are still stuck on simplifying radicals, I have had a few questions today. Remember, you take your factor tree of 27, 3 times 9, 3 times 3, and you're looking for pairs of 3s that you can pull out one. 3 rad 3. It feels like since we just simplified 2 radicals, we should be done, and that was enough work, and we're ready to move on with our lives, but I actually have one more step, right? Because the x is not alone. How do I get x alone? Minus 2. Okay. So then here's how I'm okay with you writing your answer from here. Negative 2 plus or minus 3 radical 3 over 8. However, several people today have asked me, well, don't you want to make that into one fraction? Not really, no. Because if you got successfully here, converting it to one big fraction just increases your chances of making a mistake between now and your final answer. However, if you really, really want to and you can't have peace without making this into a single fraction, that would look like this. You would need to have negative 2 with a common denominator, which would be negative 16 over 8, right? Because I need a denominator of 8. And then you just combine the numerators like this. Okay, so that's what it would look like as one fraction, if you really needed to do that for yourself. But I'm happy with the separate terms right there, because there's no other math you could do because of that radical. Does anybody need this up anymore? Do this last one. You will have an I in your answer, so don't think you're doing it wrong necessarily.